In this session, we are going to do a lab activity to verify Snell's law. Okay, by using semicircular glass slab. Semicircular glass slab. What is Snell's law? See this one. For a given pair of medium, here what are the mediums? One is the air, another one is the glass. For a given pair of medium, the ratio of sine of the angle of incident to the sine of the angle of refraction is constant. That is sin I by sin r is equal to constant. Okay, so n1 sin I is equal to n2 sin r, or sin I by sin r is equal to n2 by n1 is equal to v1 by v2. So to verify this, to do this lab activity, what are the materials needed? Semicircular glass slab. Here, see this one. I fixed the semicircular glass slab to the blackboard. This is the semicircular glass slab. Observe this one. So, semicircular glass slab and a protractor of 360 degrees protractor and scale. See this one? Scale. Okay. Next, laser light. Okay. Next, white paper. I am not doing the activity on the white paper. I am using the blackboard, complete blackboard. Are you clear? So I am doing this activity on the blackboard. You can imagine it as the white paper, no problem. Okay. Next one, pencil. Instead of pencil, what I am using? I am using the chalk piece. Okay. Now, what I am doing? First, mark 360 degrees using the circular protractor on the blackboard. Draw two mutually perpendicular lines, M dash and N dash. One is the M dash, another one is the N dash. M dash always gives, it shows interface. See this one. Here is the glass slab. I placed the glass slab such that its boundary touches this. See this one. This base of the semicircular glass slab touches M dash. It coincides with M dash. So below this glass slab there is the air, above the glass slab there is the air, again this is the glass slab. So light is traveling from air to glass slab. Are you clear about that? Now the light is traveling from air to glass slab. Are you clear? I marked 10 degrees, 20 degrees up to 90 degrees on either side using the protractor. Are you clear? Now I fixed the glass slab with the help of the tape. Okay? Now see this one. Now the angle of incident. See this one. The angle of incident is 30 degrees. Observe this one. The angle of incident is 30 degrees. Observe this one. Okay. It is not exactly 20 degrees, but it is how many degrees? 19 degrees. It is 90 degrees. When the angle of incident, give me that black paper. It is 30 degrees. When the angle of incident is 30 degrees, angle of refraction is 19 degrees. Okay. 30 degrees పతన కోణానికి వక్రీభవన కోణం ఎంత ఉంది? 19 డిగ్రీలు ఉంది. How many degrees? 19 degrees. Observe this one. Okay, here is 20, but it is not 20 exactly. 19 degrees. Next, for an angle of 40 degrees, observe this one. The angle of incident is 40 degrees. This is 40 degrees. Now the light ray is incident at an angle of 40 degrees. Observe this carefully. Angle of refraction is 23 degrees. Observe this. This is 23 degrees. Observe this. This is exactly 23 or 24 degrees. 1 or 2 degrees is considerable. Okay. Next one. For an angle of 50 degrees. See this. For an angle of 50 degrees. Observe this. For an angle of 50 degrees. See this. 29 degrees. Angle of refraction is 29 degrees, not 30 exactly. See this one. Okay. Next one. For an angle of 6, observe this. See this. 5 degrees, I think 35 degrees. Okay, so write down these values. What What is the angle of refraction when the light ray exactly incident normally? Observe this one. Observe this one. It is also 90 degrees. Observe this carefully. It is also 90 degrees. Are you clear? Okay. So write down all these values in the table. All these values in the table. See this one? I am writing these values in the table. See, for an angle of 30 degrees, angle of refraction is 90 degrees. For 40 degrees, it is 24 degrees. For 50 degrees, it is 30 degrees. For 60 degrees, it is 34 degrees. Other values which we obtained by doing this activity. Are you clear? By doing this activity. Now what you have to do is, using the calculator, you have to calculate sin I by sin R. Sin I by sin R. Are you clear? I tabulated angle I, angle R, and I calculated sin I, sin R using the calculator. I found the ratio sin I by sin R. Here it is, observe this one, it is 1.54. I considered only first two digits. Okay, 1.54 first two places. 1.54, here it is 1.59, here it is 1.53, here it is 1.55. So, the sin I by ratio of angle of incident to the sin of the angle of refraction is constant. It is approximately 1.5. How much? 1.5. So the refractive index of this semicircular glass slab is equal to how much? This semicircular glass slab is equal to 1.5. How much? 1.5. So with this experiment, we proved the ratio of sin of the angle of incident to the sin of the angle of refraction is always constant for a given pair of medium and for the given color. That is also important, for the given color. Are you clear about that? I hope you understand my concept well. If you have any doubt, please post your doubts. Okay? Right. Thank you, children.